Welcome back to Pre-Algebra, Chapter 3, Section 3 of this book, Solving Equations with Variables on Both Sides. So what that means is that what's going to make this ugly is there are x's on both sides. Oh no! But don't worry, we can do it. Okay. So we have why this is ugly. Before we can ever say why is x not alone, we have to say why is it ugly, and there are x's on both sides. That is very much uglifying this problem. I'm sure that's a word. Alright, so what do? If x's are on both sides, you look at the numbers. Don't worry about positive and negative. Just look at the numbers and figure out which one is more. And 10 is more than 7. So we're going to move the 7 to the 10. You can also move the 10 to the 7. You'll get the same answer, but it'll be a little bit harder. And I'm lazy, and I always want to do it the easiest way. So I find which one's bigger, and that one's bigger, so I'm going to make the 7 move to the 10. How do you move these things? By doing the opposite. You should have figured, right? So what is the opposite of this positive 7x? Minus 7x. What I do to one side, I do to the other. What happens to those? They cancel out. Whoop. More fun with sound effects. I bring down what I didn't mess with. Negative 5 equals, and I'm going to bring down that plus 13. And 10x minus 7x is 3x. Now, I can ask myself, why is x not alone? Well, it's got a 3 and a 13. Which one am I getting rid of first? That's right, the 13, because it is further away. And we always do what's further away and then we'll work toward what's closer to x. So how we get rid of it is by doing the opposite. What is the opposite of plus 13? Minus 13. What I do to one side, I do to the other. What happens to those? They cancel out. What happens to everything else that I didn't mess with? You bring it down. So what is negative 5 minus 13? Negative 18. Now we can ask ourselves once again, why is x not alone? It's being multiplied by 3. What's the opposite? Divide by 3. What I do to one side, I do to the other. What happens to those 3's? They get canceled out. Now then, negative 18 divided by 3 is negative 6. So x equals negative 6. Notice it doesn't matter if x is on the right or the left. It doesn't matter. You just bring it down because you didn't mess with it. Okay. Next one. We'll draw a line so you can tell it's a new problem. Why is it ugly? Because it has x's on both sides. Now, when it's like this, remember how I picked this smaller one here? Here, this one is the smaller one, but it doesn't matter. If on this side we have x all by itself, and over here we have x with other gobbledygook, then we always move the other x, to the one that's by itself, even if it's smaller, okay? But if possible, we do it that way, because I'm lazy. Alright, so how are we going to move that 5x? By doing the opposite. What's the opposite of this positive 5x? It's minus 5x. What I do to one side, I do to the other. Those cancel out. I bring down what I didn't mess with. 10x minus 5x is 5x. Now, I can ask myself the question, why is x not alone? Because it's being multiplied by 5. What's the opposite? Divide by 5. What I do to one side, I do to the other. 5's mark out, bring down what I didn't mess with. 5 goes into 60 12 times. If you didn't know that, just use it on your calculator. The more you do it on your calculator, you'll start memorizing it. Alright, why is it ugly? Well, two things. We have x's on both sides and parentheses. Which one should we deal with first? We have a clue in please excuse my dear Aunt Sally. The please stands for parentheses, so we're going to do that first. Whoop, whoop. More fun with sound effects. I always draw arrows first. because I will do the first one and I am so ditzy, sometimes I'll forget to do the second one. So every time I draw those arrows, remember I had a concussion, now I'm a little dyslexic, so I have to do everything I can to get problems more organized. And you should too, even if you're not dyslexic, ditzy, or concussed. Okay, so 5 times 2x is 10x, and 5 times 1 is 5, and you still have to have that plus there because those are different terms. And then bring down what you didn't mess with. All right, 10x over here is by itself, so I'm going to go around and move it that way. What's the opposite of this positive 10x? Minus 10x, what I do to one side, I do to the other. Oh no, either I wrote the problem wrong or else they're trying to teach you this. Hold on. Let's see if I wrote it down. Yes, 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 they are going to teach you this. Okay, so what happens to these? They cancel out. Bring down what you didn't mess with. 10x, oh, that's not 5, 5x. 5 equals 10 minus 10x is 0. Is that true? Is 5 the same thing as 0? Absolutely not. If I have $5, I'm going to the Dollar Tree and I'm getting 5 things. Woo! If I have $0, I am staying home. So this is not true, and the answer is no solution. That's the abbreviation for solution. So if you get something weird and false, write no solution. All right? I know it's kind of weird, but it's that everything ended up kind of canceling out and it made a lie. 5 is not 0. No solution. All right, let's do another one. So why is this ugly? X is on both sides, even uglier, parentheses. So we're going to draw the arrows. First I'm going to bring down what I didn't mess with over here. 2 times 3x is 6x. 2 times 1 is 2. Okay, now I'm going to move the 6's together. I'm going to do minus 6x, minus 6x. Those cancel out. Oh, but these cancel out. So I get 2 equals 2. Yeah, it does. So if suddenly you get something weird and false, the answer is no solution. If suddenly you get something weird and true, it is infinitely many solutions. Infinity solutions. You always want to use that infinity symbol for something, didn't you? It's a sideways 8. So infinite number of solutions. Infinite number of solutions. So that one's none if it's a lie. If it's true, it's infinity, like Buzz Lightyear, infinity and beyond. Okay, here's our last one. We have a rectangle, a square or something, and it's got one side is 2x, the other one is x plus 4, and the perimeter you add the 2 lengths and the 2 widths. So over here is also 2x, and over here is also x plus 4, and that will be our perimeter. Now I'm going to do a little bit of erasing because I need a little more room for this. Okay, so what I'm going to do is just write them all down, adding them up. X plus 4 plus x plus 4 plus 2x plus 2x, all of that is what the perimeter equals. So now I need to just add up all my x's. I've got 1 there, 2 there, and 2 there. But before I do, I should sing, gathering up your terms, because I'm gathering terms, baby. All right, 1x plus another x is 2x, 3, 4, 5, 6. All together, that's 6x, and 4 plus 4 is 8. So the perimeter is 6x plus 8. Now, unless they tell us what it is, we can't figure out what it is. Six. So our perimeter is 6x plus 8. That's good enough because we don't know what x is or the perimeter is. If we knew what one of those were, we could solve it. Your book is a little bit of a word problem, so I think there's a little more to it than that. So, oh, they said there's 2 things, equal. But anyway, look at the example in the book, make sure it kind of makes sense. If not, don't worry about it. This is a little bit tricky and a little bit honors level. So that's where I'm just going to leave that one. Math is great. See you next time.